Okay, so let us start today the integration and the physical meaning of integration, integration formulas, integration. So suppose if you take again any graph y and x graph, and let us say some graph is there. What is meant by integration is, suppose I want to calculate the area from x1 to x2. I want to calculate area. So if you want to calculate this area, we are going to divide it into small areas. Suppose if I divide it into a small element, this is strip. Okay, this is strip. Small rectangles. And let us take this as delta x anywhere, and this will be y. So this will be y plus delta y. So this point is like x comma y, and this point will be like um, x plus delta x comma y plus delta y. So 2 points I am taking on this graph, and here I will little bit zoom out this area. So this is a small area, means it's a small line on the graph. Graph is very big, but this is a small line, and we are trying to calculate the area below this limit. So if I have taken this as x comma y, this is x plus delta x, y plus delta y. So the area is calculated by considering this much area. So this is delta x and this is y, right? So this area of this strip which we are calculating is, let us take this area as delta A. This area is like y into delta x. Rectangle it is, so length into breadth. But note that while you are calculating this area, you are leaving this much area. Some area is missing out. That you need to understand. This much area portion is not coming into calculation. Right? This much area is missing out. This area is missing out. Missing out. Missing out area. But we want to calculate area below this graph entirely. So you think that I want to create a small element of delta x width, and I will take area and I will add all the area, then I will get the area between x1 and x2. But the thing is that when you cut is delta x length, this area is missing out. That is the problem happening. So the idea is that total area which you want to calculate, it is the sum of all this delta A. But the problem here is that there is missing out area. You will not get the total area. What is the total area? Total area is this area. I want to calculate this entire area. This entire area we want to calculate. Okay, this entire area we want, but while you are trying to take area, this area is getting missing out, so you will not get this exact area. So if you want exact area, you have to remove this missing area. So in order to do that, let us make this delta x very small. If you make delta x very small, then this area will come exact area, right? If you make delta x very small, so that this area will get reduced. So that is the idea. So this is the approximate area right now. This is the approximate area, but if you want actual area, you can apply the condition limit delta x tends to 0. This area limit you will apply. So when you apply limit on this area, so this will become, of course it is summation, not just this one, it is summation. Limit you are applying on this summation you are applying limit. Now this can be written as, when you apply limit delta x tends to 0, then this will become, this become y dx, this become ytx because delta x become dx, and this become integration. Okay, this is the main idea behind. um, are you there? This is the main idea behind integration. Integration is done in order to calculate the area below the graph. Can you hear me? Are you able to hear me, Purna? So what I was explaining is that you want to calculate the total area below the graph from x1 to x2. You are cutting a small strip or a small rectangle, and this rectangle area, when you are calculating and you are adding all that small rectangle, you are missing out some area. So this will give us approximate area, but if you want exact area, you need to make this small thickness delta x as very small. For that, you will do integration. So you have to apply limit. When you apply this, delta x tends to 0, then this summation, the limit of this summation, right, will become integration of y dx. So that is the concept of integration. And now when you are saying that I will take small, what does that mean? That means you will make very thin, so that there is no such gap between the elements. Continuously you will be taking these continuous areas. Are you understanding this? Yes? Tell me, are you understanding this? Yes, are you understanding? So that is how you are taking this area, that is what is integration. So integration gives the summation of all these small strips, which is just like a thickness of a line. So now there won't be any error. Previously there was error. Why? Because there was some missing out area, but now there will be no missing area. Complete rectangle means complete area below this graph we will be able to find out. That is the idea. Okay, this is what is called integration. Of course, here there will be limit from where to where you want to go. You want to go from x equal to x1 to x equal to x2. This is what is called integration. So integration is nothing but the limit of a summation. That is the mathematical meaning, and it also means physical meaning is that it gives the area below a graph. So any graph is there, any type of graph is there, between two limits x1 and x2, you will be getting the area below this graph. That is the meaning of integration. Okay. Now let's understand how can we convert differentiation into integration. Suppose for example dy by dx is something. Dy by dx is, let us say, some function of x. Dy by dx is a function of x. So I can write this as cross multiply dy become fx dx. Dy will become fx dx. I can cross multiply, and after cross multiplying we can perform this integration. And of course here the limit of y will be there from y1 to y2. That side the limit of x will be there from x1 to x2. So this is called finite definite integration, because we are going from a finite value of x to another finite value of x. So these are called the limits of integration. Okay, these are called the limits. One is called lower limit. This x1 is called lower limit, and x2 will be called upper limit. Okay, so this integration of y dx between the limit x1 to x2, this is called definite integration. Definite integration. Definite integration. Okay. That's the meaning of integration. That gives area below the graph. Area below the graph. and sometimes there is a indefinite integration which has no limits. This is without limit. This is called indefinite integration. Indefinite integration. Indefinite integration. And here this can give area also, but we need to know certain limits. So limits are not known, so this is called indefinite. It can be anything. That means you are not sure from where to where are we calculating. Are you calculating here to here this area, or are you calculating here to here this area? That is not sure. That is not sure. So what we will do, so when you will write its answer, suppose you got some answer, in this answer you will add a c. Okay, in this answer you will add a c. So that c is called constant of integration. That c is called constant of integration. The value of this constant is not known. The value of this constant is not known, because if you know the value, then you will know the area under the graph. So its value is not known. Okay. Right. So this is what it is. Now let us understand some formulas of integration. Some formulas we will see. So integration formulas. Integration formulas. So integration is, what is integration? Integration is opposite of differentiation. Opposite of differentiation. We should also know that integration is opposite of differentiation. For example, differentiation of sin x is equal to, differentiation of sin x with respect to x is cos x. That is why integration of cos x will give us, integration of cos x will give us sin x. So now you can understand, right? So sin x if you take, and if you differentiate sin x, you will get cos x. And the reverse is integration. If you take cos x and you integrate with respect to x, you will get sin x. That is what it is. Okay. So from this process, you can understand that integration and differentiation are exactly opposite process. Okay. So the formulas of integration and differentiation are also exactly same but opposite, right? Now let us write trigonometric function formula. So already you know, right? This is first sign. No, similarly differentiation of cos will be what? Cos differentiation we have seen, that is minus sin x. Okay, let's write differentiation formula first. Then differentiation of secant x. Secant x differentiation is tan square x. Similarly, differentiation of uh, tan x. Tan x. I think tan x differentiation is secant square x, right? Tan x differentiation is secant square x, and secant x differentiation is secant x tan x. So its opposite. Now let us write its opposite. So that means sin x, if you integrate this minus sign will go that side. Sin x integration if you do, you will get minus cos x. Okay, this is opposite of that. Similarly, opposite of this will be what? Integration of secant x tan x will give us, with respect to x, will give us secant x. Similarly, integration of secant square x dx will give us tan x. Okay, like that. Let's write another two formulas. What are that? Cot x differentiation. Cot x differentiation is minus cosecant square x. That is why integration of cosecant square x with respect to x will give us minus cot x. And the last trigonometric formula is differentiation of cosecant x with respect to x gives us minus cosecant x cot x. So integration of cosecant x cot x with respect to x will give us minus cosecant x. Are you clear about these formulas? Yes. Are you clear about these formulas? Yes. Opposite of differentiation. So tell me, any doubt in these formulas? You write this. All of this formula at least you should know. Did you write this? Sin x, cos x integration sin x, integration minus cos x, secant tan x, secant x, secant square x tan x, cosecant square x minus cot x, cosecant x cot x minus cosecant x. Did you note these formulas? Yes, Ritupurna, did you write this? Okay, then let's go next. More formulas, more important formulas I will write now. Other formulas. If you remember, in differentiation formula, we have seen differentiation of x power n with respect to x. Okay, this formula was x power n times x power n minus 1. Okay, right. So see, what I do is, instead of n, suppose if I use n plus 1, let us say instead of n in this formula, if I use n plus 1, then what happens? X power n plus 1 differentiation I will do. So this power n plus 1 will come here and we will get x power n, right? So original power comes and power decreases. Now just opposite of this is integration. If we are going to integrate x to power n with respect to x, we will get x power n plus 1 divided by n plus 1. Why divided? Because this n plus 1 will go denominator that side. That is the reason. Okay. So this is formula for integration for n plus 1 power, and this is the formula for integration for n power. Then differentiation of ln x. Differentiation of ln x becomes equal to 1 by x. So that is why integration of 1 by x with respect to x will become ln x. Formula number 8, differentiation. This side is integral. Side by side we are writing both the formulas. Next, differentiation of 1 by x, very important. Differentiation of 1 by x with respect to x becomes minus 1 by x square. So the integration of 1 by x square dx will become minus 1 by x. Differentiation of 1 by x becomes minus 1 by x square. So the integration of 1 by x square becomes minus 1 by x. differentiation of root x with respect to x becomes 1 by 2 root x. So the integration of 1 by root x 1 by root x becomes 2 root x. This is also important point. All these are very important formulas for NEEV because in physics also it is used a lot. Then exponential also formulas, let us type. Differentiation of e per power x with respect to x becomes e per power x. So integration of e per power x with respect to x becomes e per power x only. No change happens. Some sound okay. Some background noise is coming. Maybe some election people are making some. Just wait for a moment. Okay. Okay, so all these formulas are there. Important formulas we should know. Now today I will tell you certain special formulas which will help you to solve actual questions which may be little difficult. Both in integration and differentiation I will tell such formulas. Let us note that those formulas are basically based on chain rule. Some special formulas. Let us take next page. Special formulas. Suppose if I take differentiation of sine ax plus b with respect to x. I want to differentiate sine ax plus b with respect to x. Now what happens here is we have to write sine differentiation. We know sine differentiation will be cos. We will write cos, no problem. Cos ax plus b we will write. And we have some constant, okay. But the coefficient of x, you have to note here, the coefficient of x, which is a, will get multiplied here. Coefficient of x will get multiplied here. Remember this very important formula. So this idea will happen in all trigonometric derivations. Now I am not going to repeat all formulas for cos and all that. So I am just giving one example of trigonometric function. If instead of sine x differentiation, if it is sine something and that's a linear function, so in that case the coefficient of x a will come out. That is coming from chain rule. Okay, so its corresponding integration formula will be what? Integration formula will be, suppose I want to integrate, let us say cos I want to integrate. Cos ax plus b I want to integrate with respect to x. So cos integration will be sine will be there. But in this case we need to divide by a, that is what we need to note here. So in case of integration, this a which is coming will get divided here. That we need to note, right? So this is a special formula where Directly sin x will not be there, but something will be there. That a we need to multiply in differentiation, and that a we need to divide in integration. Okay. Then, are you clear about these formulas? Okay. Then, suppose I have to do, let us say, for example, I have to differentiate ln ax plus b. Linear function only, linear function. It should not be quadratic. With respect to x, I want to differentiate. Then this differentiation will be 1 by ax plus b. Again, the coefficient of x, which is a, will get multiplied here, so a will come in the numerator. So this is what we need to see. The a will be coming numerator. So in differentiation, the coefficient of x will come in numerator, but in integration, it will get divided. So suppose if I integrate 1 by ax plus b with respect to x, then this will become ln ax plus b, but b will get, sorry, a will get divided. That's what it is. This a will come here. Like that, you have to apply wherever linear function are there. In those linear function, this pattern will be there. In all such linear function, the same pattern. Of course, if it is a quadratic equation, then we cannot use this idea. This formula cannot be used. But generally, in mid level questions, they will give linear function. So linear function we can do like this. In differentiation, we'll multiply, and in integration, we'll divide coefficient. Okay, so that's all. I think this much. One more, let us write for the power formulas, because that is also used a lot. So third one, exponential, will let us write. So differentiation of, let us say, e per power ax plus b is there. Okay, with respect to x, differentiation. So this become e per power ax plus b, and the coefficient a is multiplied. Okay, coefficient a is multiplied here. Now, in case of integration, suppose I want to integrate ax plus b with respect to x. Then in this case, it will remain same e to power ax plus b, but that coefficient a will get divided. That is the idea. And with this, we have finished this formula. So if you know all these formulas, then you can solve any tough type of questions. Okay. First of all, the foundation of all these formulas are there, and I have told you also that already I have recorded for all type of students basic maths, a short term course I launched on YouTube long back in 24. Okay, for JEE main student as well as NEET, it is important that it is almost till first volume up to, I think, solids I have covered. Up to solids I have covered, but that is not like a video teaching on digital board. That is on a screen recorded. Okay, screen recorded videos are there. So you can watch that. First chapter start with basic maths. All the kind of maths I have covered in very detail. All the important formulas of integration, differentiation, binomial expansion, coordinate geometry, trigonometry, everything, all this shortcut has been covered. So if anybody can go through all that, he will be able to strongly, get in all these problems, right? So very important. If you have time, you can watch that. Okay, so let us now go into, remember last class we told that we have to discuss about shape, sorry, this, what are the things, five things were there. What were there? Slope. In a graphical concept we are discussing slope, then what? Shape, slope, shape, area. Slope, shape, area, three concept we finished, right? Slope, shape, area. Then what else? Mean value and this RMS value, two concepts are remaining, right? Mean value and RMS. Mean means average. So let us take that fourth concept, mean or average. Mean value or average value. So suppose, for example, we are discussing graphical concept, okay, in the graphs. From graph, how can we understand? So what is mean? So mean value of y or average value of y means over an interval, suppose y is changing. So this will be like integration of y delta x divided by delta x, and here the interval is from x1 to x2. So lower limit is x1, upper limit is x2. So delta x is nothing but x2 minus x1. Okay, delta x is nothing but x2. So this is called average value. Average value, very important concept. It is used in the calculation of average velocity, average displacement, average accelerations, all those things we can use. We will see examples. Here y can be anything, x can be anything. Some graph will be given, let us say some graph is given, and they ask you find the average between x1 and x2. Average will always be calculated between an interval, right? So this interval x2 minus x1, this is what is delta x. So if they ask average, you can calculate the area under the graph, because you know integration of y dx means area under the graph. So this area, if you can calculate this area is this integration. So just calculate this area divided by delta x, that will give us. Now it's important. Let us try to do this. Some calculation. Let's see in physics. Suppose they give velocity. Uh, they give velocity. Yes, velocity time graph. They give velocity time graph. Suppose this is velocity time graph, and let us say the graph is given like this. Initial velocity time 0, let us say 10 meter per second. Velocity is in meter per second, and they are asking from time 0 to time 10 second, and this graph is given. Equation of this graph is given. V is equal to 10 plus 3t. Okay. So the equation of this graph is given, v equal to 10 plus 3t. Now you need to find the average velocity between 0 and 10 seconds. Calculate. Find average velocity between time 0 and time 10 seconds. Calculate. Any answer? Yes, Shruti, any answer? This is the average calculation. Okay, that means you know already the value of here, because 3 into 10 30 plus 10 40. So this is 40, right? This value is 40. You want average. Don't think that average is 10 plus 40. Maybe sometime it is possible, but not always. Here I think mathematical average is there. Check. Might be mathematical average it will be there, right? You use this formula, but you use this formula. I will tell you to use this formula. This is the main formula. So average velocity here will be how much? Area under this graph. Okay, area under this graph gives us what? Area under this graph gives us what? What does area under velocity time graph give? How does, do you know? Because velocity is dx by dt, you know that. So v dt gives us dx, and when you integrate this side, this gives area under velocity time graph, and this integration of dx is delta x. So integration of velocity time graph gives us displacement. Okay, integration means area under graph. Area under graph gives us displacement. So average velocity is defined as displacement by time. That is why we have written this. Displacement is delta x, which is area under graph, divided by time. So time interval already we know 10 seconds, and area under this graph you can calculate half into base. Base is nothing but sum of half into, this is trapezium, no? Half into sum of parallel side into height. Parallel side is 10 plus 40 into the height, which is 10. So here you can see that this becomes average of, right, average of this velocity, mathematical average 10 plus 40 by 2, 50 by 2, 25. Are you clear about this? Yes, mathematical average. So but note that this mathematical average is true only for this straight line. Why? Because only for a straight line area of trapezium comes. Now suppose if the graph is a parabola or hyperbola, then this average, average idea will not work. It is not going to work. Let me give you another example to show that this area average method will not work unless you use this actual formula. Same question I am going to repeat. Same question, but I am now going to make a parabola. Okay, this is velocity versus graph, time graph, and this graph is, let us say, v is equal to t square. Calculate the average between 0 to 10 seconds. Repeat the calculation, and you know the value of 0 is 0, and value at 10 second will be 100 t square, right? Now if you use mathematical average, so 0 plus 100 divided by 2, that means 50 it should come, but it will not come 50. Use this method. Use area under graph. What will be the area under this graph now? You know integration? Come on, do it. Displacement will be area under this graph. Area is velocity time graph from 0 to 10 seconds. Velocity is t square. T square integration, you know. Do it. T square integration is t per power 3 by 3, and it will go from 0 to 10. So it will become 1000 by 3. See how to solve this integration. You need to first put the upper limit 10 cube by 3 become 1000 minus lower limit you have to put 0 cube by 3. So the value of this displacement will come as displacement value will come as 1000 by 3. This is what is displacement. Now what is the average value? Average velocity is displacement by time. Displacement has become 1000 by 3 and time has become 10, so this will become 100 by 3. 100 by 3 you will get 100 by 3 means 33.33. Are you getting this? Tell me. Any doubt in this question? If you really understand, then tell. Otherwise, I will explain. Any doubt is there? Hmm. Before that, hmm. How this has come? See here, the denominator here trapezium. Now trapezium area is what? Trapezium area is half into sum of parallel side tan and 40 into height. Height means this one. This width is the height. Okay. This base is height. Okay. This base is called height. Parallel side is tan. This is tan, and this is how much? 40. Half into sum of parallel side into this height. This height is tan. Clear? That's the area. For see to calculate this area, you don't have to do integration. Why? Because it's a simple figure. Triangle, rectangle, trapezium is a simple figure. For that, you don't have to do integration. Right? Clear? We clear about this. So half into sum of parallel side into height divided by the time interval 10. This will got cancelled 25. That means what? That means suppose if a graph is a straight line. Suppose if a graph is a straight line, then its average is just starting for initial and final value divided by 2. Okay. So if a graph is a straight line, then its average is initial value plus final value divided by 2. This is a shortcut. You can use it. For this, you don't have to worry. And actually, if velocity time graph is a straight line, tell me, tell me whether acceleration is constant or not. Tell me. Suppose velocity time graph is a straight line. Is acceleration constant or not? Yes. Okay, tell me what is the slope of velocity time graph? What is okay? Tell me acceleration formula. Acceleration formula is what? dv by dt. Correct. This is acceleration formula dv by dt. Velocity time graph. Velocity time graph dv by dt. What is dv by dt in this velocity time graph? Um, no. See what? First understand what is the. I think you should understand this dv by dt means dy by dx means what in a graph. What is dy by dx means? What is the meaning of dy by dx? Forgotten? Last class. Did you watch the video or not? You should watch video. Already I am recording and putting in this YouTube channel. dy by dx, you remember now, slope of the graph. If a graph is there, dy by dx means slope of the graph. So in velocity time graph, dv by dt will give what? It will give slope. You remember that? Yes, that is slope. So here the slope means, and it's a straight line, so straight line slope is tan theta, that you can easily calculate now. Tell me what is this theta, tan theta? This is how much? This is tan, and this is how much? 40 minus tan, 30. What is tan theta here? 30 by tan, 3. Yes, tan theta is 3. So that is what is the acceleration. Acceleration is constant. Yes, you are right that velocity is increasing, but acceleration is constant. It is increasing at a constant rate. So if the acceleration is constant, then the average velocity formula is the mathematical average. This is the shortcut you are understanding now. Suppose if the body is going with initial velocity u and final velocity v and acceleration is constant, uniformly accelerated motion, then average velocity is u plus v by 2. That is the formula. Clear? Are you understanding this shortcut? Okay, now coming back to this question, but this formula will not work in this case because the graph is a non-linear graph. It is not a straight line graph, so that formula u plus v by 2 will not work here. Why? Because you have to take area. Now area is integration you have to do. So that's what we have done. We got this 1000 by 3. Because if you take mathematical average, suppose you take mathematical average, we got 33.33. If you take mathematical average in this case, mathematical average will be 0 plus initial velocity is 0, final velocity is 100, 0 plus 100 divided by 2, I will get 50 meter per second. So this is not correct. This is not correct. Okay, this is wrong. We have to apply the integration, then only it will give the answer, right? So this is the idea about the uh, average value, not mathematical average. Note that whatever we are understanding, the average value is not mathematical average. It can be mathematical average only when the graph is a straight line. If graph is not a straight line, it will not be the mathematical average. The average that we are discussing, it is not necessarily the mathematical average. It is based on this concept. Okay, right. Then last was what? RMS. RMS value. Let us discuss RMS value. RMS. RMS value. This is very important in grade 12 when you will go into alternating current chapter. Many other chapters you will see this RMS value applications, root mean square. Even in grade 11 you have completed syllabus. Tell me, where have you studied root mean square value? Where have you, which chapter you have studied in grade 11? Yes, where have you studied in grade 11 RMS? Hmm, right. Kinetic theory, RMS speed you have calculated. Okay. So what is the meaning of RMS? So suppose again this is a graphical concept. Suppose this is y and this is x, and I want to calculate the RMS value of y. Of course, over a interval, so it will be defined as root under integration of y square dx going from the limit x1 to x2 divided by the interval of x, which is delta x. Okay, this is the definition of RMS. RMS definition is this. So definitely this is RMS definition. But for NEET purpose, sometimes they can not, they will not make difficult question. Sometimes they will give you y square graph itself. If they give y square graph itself, then this y square dx is nothing but area under y square graph. Note that. Suppose this is y x graph, but if I have y square x graph, y square x graph, and I have this area, okay, some area is there, let us say. So I have the area, or I can calculate by some way. If I can calculate the area under y square x graph, then note that this integration of y square dx is nothing but this area which we want from here. This area we can calculate. Okay. So this area under this graph between the limit x1 and x2, y square x graph, but sometimes they will not give y square graph, they will give y graph. So y or y equation they will give. From y equation you have to find y square equation, and then y square integration you can do, right? This is the main. Let us take one very good question on this and try to see its application. Okay, try to see the application. Let us take the same previous question which I have given there. No? Previous question I give, no, that is straight line graph, let us say. So I am saying now this velocity time graph. Remember that graph I have drawn, right? That graph. Ah, yes. No, no. Y square x graph, that area you have to take. Okay. Y square x graph area you have to take. We cannot like three. You tell me. No, 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 no. We cannot use, because this integration is with respect to x. Na. Why you need to bring a function of x? Then only you can use formula. I understood your question. You are saying that should we use this formula, x to power n dx is equal to x to power n plus 1 by n plus 1. This formula you are saying, right? Correct. This we cannot use because this is x. All everything should be in x. Then only we can use. Here this is y and this is x. We have to bring y in terms of x. Then we can use it. Okay. So before we do that, let's try this question. We will be clear with this question. Same graph I am giving. Okay, this value v is equal to 10 plus 3t. This is the law. Okay, so time 0, the velocity was 10. And again said, let us take 10 second only. And this value we have calculated was 40. Okay. So now the question is find RMS velocity between this interval 0 to 10 seconds. Find VRMS between 0 to 10 seconds. So here first of all this area we need to calculate v square. So what we need to do is we need to first calculate this v square dt between the interval 0 to 10. And now because we know v function 10 plus 3t, so 10 plus 3t whole square, this we have to do, okay, from 0 to 10. Now you can apply formula. Okay, now you can apply formula. So now how will you apply formula? Tell me, how are you going to apply this? Did you practice last time? I think if you would have solved the some questions on the, differentiation, then some idea will be there. But I have given you a special formula. Remember, it's now a special formula I discussed. You can use that small special formula. 1600. First, let me tell you the special formula here. So you were saying now if it is like y square so y cube by 3, you will do same manner. You think like that only. This is whole thing. This whole square is there because it's a linear function. You can apply this special rule. It's a linear function now. So this square can be written as 10 plus 3t whole cube divided by 3. But one thing more you have to do. Can you tell what is one thing more you have to do? It is like x cube or t cube. So this cube by power you have increased and divided. But one more thing you have to do in special formulas. I told no. What is that? Do you remember? Coefficient. Remember coefficient. This coefficient is there na. This coefficient you have to divide by 3. That coefficient you have to bring extra. Remember that. Extra factor you have to bring a coefficient. Are you getting this? Are you understanding this? This is like the squared, so power increased by 3. This 3 is because the power has increased. But this 3 is because coefficient of t was 3. Remember in differentiation we multiply the coefficient, in integration we divide the coefficient. Are you getting this? Yes? Tell me any doubt in this step. So once you got this step now you can put the upper limit and lower limit. Now you put upper limit. Upper limit is 10 now. So now first you put, so 9 has come out in denominator. Put upper limit as 10. So 10 plus 3 into 10, that was 40, right? 40 cube minus lower limit you have to put, time was 0. So that means it is 10 cube by 9. Now tell me how much it will be. Solve it now. So 10 cube by 3 I will take common, okay? It will be easy to do this calculation. Then it is 4 cube minus 1. 4 cube means 4, 4, 16 into 4, 64. 64 minus 1, 63. Oh, this is becoming a good problem. It is getting cancelled, right? 9, 7 times. Correct. It has become 7,000. Right? Good problem it is. So you have calculated area of V square, right? Now you take RMS value. So what is RMS formula? Root under integration of this V square. V square dt integration between that limit 0 to 10 divided by the time interval which is 10. Now you do this. What will be the answer? Tell me. Root of 7,000 divided by 10, that means root of 700, which means 10 root 7 meter per second. Are you getting this? Yes? Tell me. Is this clear? Whatever it is, you tell me clearly. If you are not understanding, then we'll discuss. Yes, Utipurna, tell me. Any step you have doubt, you ask me. Any step. No doubts? Are you clear about this? Okay, good. So done. I think those 5 concepts we discussed, we have finished that. Okay. So coming back to the kinematics, in between maths was involved, so we had to come in the graphical concept. So differentiation, I have already told the meaning. Now integration in the graphs, what is the application? So now I will give a summary of that. So if it is velocity time graph, if it is acceleration time graph and acceleration time graph, and if it is acceleration position graph, three graph area will have also application. In these three graph we have applications of areas. What? Suppose this graph is some graph like this. So you know that acceleration is dv by dt. First of all, you know this acceleration is dv by. So if I cross multiply, acceleration dt becomes dv, and then if you integrate both sides, this acceleration dt, that is the area under this graph. Sorry, no, not this one. Sorry, velocity is equal to dx by dt. V dt is equal to dx. Then integration, if I do, this is integration of v dt means area under this graph, right? Y x graph. This will give us displacement. This is what we have to note here. So this is what? This is area under velocity time graph. Area under vt graph. Area under velocity time graph will give us displacement. This is the first application you have already seen now. Okay. Next, what is this acceleration time graph? So acceleration is dv by dt. Again, same thing, repeat, acceleration dt is equal to dv, and then you integrate both sides. So this integration a dt is equal to delta v. So this gives us what? This gives us area under acceleration time graph. Gives what? Change in velocity. This is area under acceleration time graph, AT graph. Area under acceleration time graphs gives us what? Change in velocity. Area under velocity time graphs gives us what? Displacement. Now coming to this one. Acceleration can also be written as v dv by dx. Why it is written as v dv by dx? Because acceleration is dv by dt. But I can write this as dv by dx into dx by dt. Chain rule. dv by dx and dx by dt. dx by dt becomes velocity. So dv by dx into velocity. Okay. So that is why acceleration can also be written as v dv by dx. And now if I write this a dx is equal to v dv, then I can do integration. So this integration a dx is area under ax graph, and this integration, let us say speed is going from u to v, then it will become v square by 2, and when you put limit it is v square minus u square by 2. That also you can do. So v square minus u square by 2. So v square minus u square by 2 gives us what? It gives us area under acceleration position graph. Note that. This is a very important concept. This is giving us area under AX graph. Area under AX graph. AX graph. Area under AX graph gives this. So these three applications in integration and the graph, you know, now you can definitely score very good marks. Are you okay with this? Okay, so now I think we are done with this. No, kinematics is over. Most of the part is over. Then you need problem solving. Okay, so first I want you to solve questions. One more class I think we have to take because on kinematics, because in that we need to cover motion under gravity. Motion under gravity, relative motion. Two things are remaining. Okay, and types of motion. uniform motion, uniformly accepted motion. So some of the things you will be knowing, but we need a separate class for that, right? So right now I think we have covered this much. Now you need to solve questions. If without solving question, it will not come. So I will send, already send the link. One more link I will send. Two links of test I will send. Now you solve that. I think you see the time. It's a time based test. Okay, within that time you have to solve. So you fix your time that I want to sit for 1 hour and I want to solve and I want to give the test. Then once you give the test, result will immediately come. Okay, you have to download the app. You can download the app, that will be better. Okay, so you can write the test and see that. Then some error will come. We will discuss whatever it is. Okay, fine. And you have any students, like any friends of you who are also interested? They can also join. You check them if they are like day scholars, some of those who are day scholars, because you will be going in hostel, right? After that, you may not be able to attend classes. So, if any of your friends who are in day scholars and they want to join, I can start, but I will take very less fees. I will not charge more. Okay? If they are okay, they can do whatever they. But interested means serious students, okay? Not those who are time pass. Time pass means it is difficult to teach. Those who are really want to crack NEET, you just see any of your serious friends out there. Okay? Bye bye.